Alright, in this video we are going to be talking about Doppler effect. Doppler effect. Now, Doppler effect is the apparent change in frequency of sound that occurs between a wave source and its observer. Okay, it is the apparent change in the frequency of sound that occurs between a wave source and its observer. Now, the apparent change gives rise to a new frequency, which is known as the apparent frequency. And mathematically, the apparent frequency f prime is equal to the actual frequency in brackets the velocity of sound plus or minus velocity of observer all over the velocity of sound minus plus the velocity of source. All right, so this is our equation for the apparent frequency from Doppler effect. All right, do not forget f prime is our apparent frequency. Apparent frequency. Okay, and then f is the actual frequency. V is the speed of sound, or you can call it the velocity of sound also. Speed of sound. VO is the speed of the observer. Speed of observer. And then VS is the speed of the source of the sound. Speed of source, right, of sound. Now, what Doppler effect is all about? Basically, just picture a situation whereby we have a police car approaching a particular town, let's say town A. We discover that as the car approaches town A, the sound of the police siren becomes louder. All right, that change in the frequency of sound of that siren is what we call Doppler effect. Okay, the same thing happens with when the police siren is now, or the police car is now leaving town A. All right, moving out of town A and then maybe going back to where it came from. All right, as it moves away, you discover that the frequency of the sound becomes smaller or reduces, or the sound of the sound reduces. So that change in the frequency of sound due to motion or relative motion is what we call Doppler effect. Now, in Doppler effect, there will be motion. All right, from my explanation, you understand that there will always be motion when we are talking about Doppler effects. Motion of the source of the sound or motion of the observer. All right, and the motion of the observer will give rise to velocity or speed of sound, or speed of observer, VO. All right, and they will also have the motion of the source of the sound. In this case, this example I gave to us, the police siren, which is the source of the sound, is moving. All right, so we're going to have velocity of source. Now, we also have cases where the observer can be stationary or the source can be stationary. Okay, in that case, you just need to understand this. If you have a case for, let's say, the observer moving, for observer moving, okay, and then source stationary. Source stationary. All right, source stationary simply means the source is at a spot, it's not moving. In that case, if the source is stationary, simply means the source is at rest. All right, so it means the velocity of source will be equal to 0. All right, so this is a case for observer moving and then source stationary. Velocity of source will be equal to what? 0. So what will now be our equation? Our equation basically is now going to be, we're going to have that our apparent frequency will be equal to the actual frequency multiplied by, we have velocity, all right, of the sound, plus or minus velocity of observer. Do we have velocity of observer in this case? Yes. All right, the observer is moving, so you're going to have velocity of observer or the speed of observer all over, we have the speed of sound again, we have v, but then vs is 0, so there's no point writing it here because the source is stationary, so vs is 0. So whenever we have source stationary, all right, and observer moving, this will be our equation for the apparent frequency in Doppler effect. All right, now for a case where you now have the source moving and observer stationary, so say for source moving, for source moving and then observer stationary. Observer stationary. If observer is stationary, the speed of observer or the velocity of observer will be equal to 0. Okay, so our equation now for Doppler effect or the apparent frequency, okay, will now be, we'll make reference to our original equation. So our equation now is going to be apparent frequency equals the actual frequency, in brackets we have the velocity of sound all over, there's no point writing velocity of observer again because it is 0. All right, so we ignore it. Then we have velocity of sound all over velocity of sound minus plus velocity of source. So this is going to be our equation. All right, please note the difference for source moving, observer stationary. All right, for observer moving and then source stationary. Now if you observe carefully, you discover that we have plus or minus, minus, plus, and all of that. Now in a question, you don't use both the plus and the minus. It's either you're using minus or you're using plus. So when do you use plus and when do you use minus? Now here we use plus, okay, when observer, all right, don't forget this is a case of observer moving, so we use plus when observer moves towards the source. All right, observer is moving. For this case, we have observer moving and source stationary, so we use the plus sign. Okay, we use plus when the observer is moving towards the source. So our equation now, if observer is moving towards the source, our equation is going to be f prime equals f, and then we have v plus vo all over v, no minus, all right, because the observer is moving towards the source. All right, and then number two, we use minus, all right, that's the minus sign here, when the observer, when observer moves away moves away from the source. All right, please take note of this. You can write it down. It is very, very, very important. All right, and then here we are going to use minus. Use minus when the source moves towards observer. All right, and then we use plus when observer, sorry, when source rather, when source moves away from the observer, moves away from observer. All right, this is very, very important. Okay, you use the positive sign in your equation here when observer moves towards the source. Then you use the negative sign in this equation when the observer moves away from the source. All right, so this is for observer moving. Observer is the one doing the movement, and then source is stationary. And then here for source moving, observer is now stationary. We use minus, okay, when the source moves towards the observer, and use plus when source moves away from the observer. If you observe very well, here we have towards, away, towards, away, towards, away. The same thing, towards, away, towards, away. So that's just how to memorize this. Okay. Now, just like we have observer moving, source stationary, source moving, observer stationary, we can also have cases where both the observer and the source are moving. All right, and that's where this equation becomes handy. Both the observer and the source are moving. So now, when do we use plus and when do we use minus? The same thing applies here. Observer moving towards source, you use plus. All right. In the question, if the observer is moving towards the source, you use plus. If it is moving away from the source, you use minus. The same thing here. Source moving towards observer, you use minus. Source moving away from the observer, you use plus. All right. So this is just the equation for the apparent frequency in Doppler effect. So now we are going to look at some very important examples. Now in this question it says sub A, which is the source, travels at 8 meters per second, emitting at a frequency of 1400 Hz. The speed of sound in the water is 1533 meter per second. So B, observer, all right, travels at 9 meter per second in opposite direction. So you see, this is a case of source moving and then observer also moving. Source A travels at 8 meters per second, emitting this frequency. So B, all right, travels at 9 meter per second in opposite direction. All right, the opposite direction here is to tell you if they're moving towards each other or away. All right, that's the essence of this. Now they say, what is the apparent frequency heard by the observer as the subs approach each other? Now we know that apparent frequency is equal to the actual frequency multiplied by velocity of sound plus or minus velocity of observer all over velocity of sound minus plus velocity of source. All right, so now what do we do here? You observe that this is a case where both the observer and the source are moving. They said sub A, which is the source, travels at this, so this source is moving. Sub B, which is this observer, travels at this, so both the source and the observer are moving. So we have to use this formula and not the other two, okay, which we derived earlier. So how do we go about this? Now, the issue now is whether to use plus or minus, or to use minus or plus. It is very easy. Very, very easy. Now, how do we know the sign to use? It says sub A travels at this, emitting this. The speed of sound in the water is this. They give us V. This is our V. Now, sub B travels at 9 meters per second in opposite direction. So it simply means we have sub A moving in this direction, and then we have sub B moving in this direction. So you see that they are moving towards each other. Even the question they said, what is the apparent frequency heard by the observer as the subs approach each other? All right, they are approaching each other. So this will guide us on the sign to use, whether to use plus or to use minus, or to use minus or to use plus. All right, so let's get it done now. Now remember, apparent frequency is equal to the actual frequency. In brackets we have the speed or velocity of sound. Now which one do we use, plus or minus here? Now remember, we use plus when the observer moves towards the source, minus when the observer moves away from the source. All right, now which one here is our observer? So B is our observer. Is it moving towards the source or away from the source? Is B, so B moving towards the source or away from the source? You see that, so B is moving towards the source. And whenever we are moving towards the source, remember we said we use plus. So we have V plus VO all over the speed of sound again. Now we have minus plus. Now when do we use minus here? We use minus when the source is moving towards the observer, and we use plus when the source is moving away from the observer. Now you ask yourself, the source here, which is sub A, is it moving towards the observer or away? You see that it's moving towards the observer, so we use minus Vs. All right, because the source is moving towards the observer, which is sub A, so we use this. So now the next thing now is to just plug in our values and get our final answer. So we have apparent frequency equals actual frequency, which is 1400 hertz. So we have 1400 multiplied by the velocity of sound. It was given to us in the question. They said the speed of sound, or the speed of sound in water is this. Okay, so we have 1533 1533, all right, which is the speed of sound, plus the speed of the observer. The speed of the observer, was it given to us in the question? Remember, so B is the observer, it travels at this, so we have plus 9 all over the speed of sound again is 1533 minus the speed of the source of sound. The speed of the source of sound. Our source of sound is 8 sub A, so it's moving at 8 meters per second, so we have minus 8. All right, so we just put this in our calculator and we get our final answer. So if we use our calculator to check this out, we're going to have apparent frequency equals 1415.61 hertz. Now in this question, they said, suppose a stationary siren emits a lot of frequency of 440 hertz as the train approaches it with 30 meters per second. What frequency will be received on the train? Speed of sound is 331 meters per second. So here we have a siren and we have a train. So which is our source of sound? This siren is the one emitting the sound, so it is the source of sound. So we have velocity of source to be equal to, now they said the siren is stationary, so velocity of source is 0. And then they said emits a lot of frequency. This is the actual frequency of the sound, so we have actual frequency to be 440 hertz. You see that as the train approaches it with 30 meters per second. Now the train is the observer because they say what frequency will be received on the train. Okay, so we have velocity of observer here to be 30 meters per second. So what frequency will be received on the train? So we are looking for the apparent frequency. All right. Now the speed of sound is 331 meter per second. So V was given also to be 331 meter per second. All right. So how do we go about this? We just need to remember that the apparent frequency of sound in Doppler effect is equal to the actual frequency multiplied by the speed of sound plus or minus speed of observer all over speed of sound minus plus speed of the source. Now this is a case where the source is stationary, so the whole of this will cancel out because it's zero. So our equation now is going to become apparent frequency to be equal to the frequency of the actual frequency, which is 440, multiplied by the speed of sound was given to us to be 331. So we have 331, and they said plus or minus. So which do we use? Plus, you use plus when the observer is moving towards the source, and use minus when the observer is moving away from the source. So now they said as the train approaches approaches what? The siren, the stationary siren. The train approaches. So in this case, the observer, which is the train, is moving towards the source because it's approaching it. So we use plus. Right, plus the velocity of observer, which is 30 all over 331, and that will give us the apparent frequency to be equal to 440 and that will give us the apparent frequency to be equal to, we use our calculator to get this out. So we have 479.88 hertz. So this is our answer to this question. Now, our next question here says a police siren has a frequency of 800 hertz. All right, so this is the original frequency, so we call it the actual frequency to be 800 hertz. If the velocity of sound in air is 344 meter per second, so we have the velocity of sound to be 344 meter per second. Okay. They said determine the frequencies heard by drivers of vehicles. All right. So we're looking for the apparent frequency. Okay, heard by drivers of vehicles moving at 14 meter per second. Now this 14 meter per second is the velocity of the vehicle. Now the vehicle, is it the observer or the source? They say the police siren has a frequency of this. All right, so the police siren is the one making the sound, whose frequency is this. So the police siren is the source of sound. The vehicles obviously will be the observer. Now they say the vehicles are moving at 14 meter per second. So we have velocity of observer to be equal to 14 meter per second. All right, so in this case, we're going to have that the apparent frequency equals, we're looking for the apparent frequency here. Now recall, we know that apparent frequency is equal to the actual frequency multiplied by the velocity of sound. All right. In this case, we have observer moving. All right. So obviously the source of the sound, which is the police siren, is stationary because they did not give us the velocity of the source. So we're going to have velocity of sound plus or minus velocity of the observer. All right. All over the velocity of sound. No velocity of source because it is zero. Okay. The source of the sound, which is the police siren, is not moving. No velocity was given for it. Now, the question is very easy. They said, determine the frequency heard by drivers of vehicles moving at 40 meters per second. The first question here says, heard by drivers of vehicles moving at 40 meters per second towards the siren. Towards the siren. So we have here the observer, okay, which is the vehicle moving towards the siren. Now, you know, whenever we have observer moving towards the source of the sound, we use plus. So our equation here will be apparent frequency to be equal to actual frequency multiplied by the velocity of sound, which is 344, all right, plus velocity of observer, which is 14, all over 344. Okay, we are using plus here because we have the observer moving towards the source of sound. So if we use our calculator to compute this, we are going to have the apparent frequency to be, our actual frequency is 800 hertz. So we'll substitute it here also. 800 hertz. So we're supposed to have 800. Okay. So we'll use our calculator now to get our answer. And that will give us the apparent frequency to be 832.56 hertz. Okay, and then the second part of the question, this is our first answer. Please take note. Now, the second part of the question, we're going to have apparent frequency equals the actual frequency, which is 800, multiplied by the velocity of sound, again, which is 344. Now we have plus or minus. Now in this case, we have the observer moving away from the source, which is the siren. Okay, the vehicle is moving away from the siren. So we are going to use minus, okay, because whenever observer moves away from the source, we use minus. So that will give us 344 minus, we have 14, all right, which is the velocity of observer all over 344. And that will give us the apparent frequency to be equal to we have 767.44 hertz. So that's our answer to this question. Now, please do well to subscribe to this channel if you found this video helpful. Also like the video and drop a comment.